Okay, it's 1 o'clock and it's time for our keynote. This is the first conference I've ever been to where the keynote is actually after the session's open. But as someone who never makes the keynote because I'm always asleep, I'm really happy we did the keynote after lunch. This is Peter Losher from, oh, you did put CV on there. This is Peter Losher from the Internet Software Consortium? Systems Consortium. ISC, who you may know of, they do things like run the effort and produce software like Bind and ISC-DHCP. And he's going to talk to us today about something. We're going to find out in about a second. I guess I could read the program, but I'm really late. Okay. So, he's going to talk to us about ISC and BSD at the core of the internet. I guess that's about all I have to say about Peter. So why don't you...
You're stopping talking?
Yes.
Right. Well, very happy to be here. Many thanks to the AsiaBSDCon organizers for asking me to come and give one of the keynotes. The CVE is sort of an inside joke. It means Certified BSD Enthusiast or Evangelist, depending on your point of view. So what I'm here to talk about is about ISC, but in a way that since we are a very big user of BSD, to sort of show how we go about things. So I'll talk a little bit about ISC. I'll talk a little bit about ISC operations. I'll also talk about living the DualStack life with IPv6, as well as talk a little bit about f.rootservers.net, which most of you probably heard of. And then, last but not least, what do we actually do for the FreeBSD community? A little bit about ISC. We were actually incorporated in 1994 as Internet Software Consortium. That's how many of you probably know us as. We recently changed our name and were granted 501c3, which is in U.S. tax terms a nonprofit. So we're headquartered in Redwood City, California, just north of Silicon Valley. Our mission is to develop and maintain high production quality software like Bind and DHCP. We strive to be the industry reference implementation wherever possible. So Bind is obviously that way for DNS, and DHCP is that way for DHCP. We try to enhance the stability of the global DNS infrastructure by f.rootservers.net, as well as some of our secondary name server operations, and we feed all that through a crisis coordination center called OARC for DNS. We also do further protocol development in the areas of DNS evolution. A couple of things that we've been focusing on is DNSSEC, so secure DNS, as well as facilitating the transition to IPv6 with DHCP version 4, which ironically is our first client-server implementation for IPv6. So, we are also developing a network backbone within starting with the San Francisco Bay Area for easier distribution of public benefit content. So I'll talk briefly a little bit about that, some of the content that we actually distribute. But for this, we're actually starting out with like a dark fiber backbone in the Bay Area. Hopefully we'll be able to extend that to Asia, as well as eastward to the east coast of the US and perhaps into Europe. Oh, by the way, my date is dead, thank God. This has been an inside joke inside the company for a very long time. We have been trying to kill Bind 8 forever and ever and ever and ever. Unfortunately, vendors like shipping with it. So to commemorate the fact that we finally said no more, no MOS, unless it is like a critical remote root compromise, we're not going to ever release another version. And by the way, That is bind 4. There was one vendor who shall remain nameless until about 3 or 4 years ago was still shipping an OS with bind 4 in it. Fortunately, they finally saw the light. A little bit about our operations. We have staff based in the US and in Europe, in Amsterdam. We are big deployers of Anycast technology. Now, for those that don't know what Anycast is, it's basically a routing protocol, a way to route packets to have multiple ways to get to an IP. So if I have 2 servers inside of a data center that are advertising the same IP address, I can use a routing protocol like OSPF to advertise to the upstream router, hey, I'm advertising this address. And so when the request comes in, it comes into the router tries to decide how to route the packet. Usually the way we use it is equal cost path. So it usually does like 55%, 45%, one to the other. So it routes the packet to the closest server. If both are equal cost, then it just picks one at random via the algorithm. We use that a lot for our production services and also for F, which I'll get into briefly. We're very big into DNS operations with f.rootservers.net. We also have a service called nsext.ic.org, which is our public benefit secondary service. It's all non-commercial zones. We host several hundred, actually 500, 600 zones, as well as 30 plus CCTLDs. So the Netherlands, France, Christmas Island. We actually had Antarctica for a while too. So we're there for as an infrastructure play. So when new CCTLDs show up, they want an alternate name server. We're usually the people they come to talk to. Or if a country feels that they're not getting good enough service and they don't want to outlay the infrastructure cost to build their own servers, they usually come to us. Being a nonprofit, they know we're not normally going to gouge them, and we usually say, yes, we'll do it for free. Because, well, this is how we make the internet work. NSNE, that's just a project name. Currently, NSEXT is basically locally Anycast within the Bay Area. We have several servers inside the Bay Area that advertise that address. We want to take that global. So we're going to go into several locations in North America, Europe, and hopefully after that in Asia, South America, and Africa, and basically have a way for public benefit organizations, anyone from the NGOs, so like Red Cross, to a CCTLD operator, to a fellow nonprofit. We're slightly restricted because we're a US nonprofit in what we can take. We can't take political organizations and religious organizations. But other than that, if you're a nonprofit, it's free for a secondary DNS service. So that's one of the things I'm actually working on when I get back to the office, is getting this launched. Unfortunately, that's not going to run on BSD. The hardware vendor that a lot of the way we operate are via grants and hardware donations via top vendors. And in this case, the vendor supplied us with Itanium boxes. So we're going to be running Debian, unfortunately. But so another thing we actually do is hosted at ISC. Hosted at ISC is part of our way to give back to the community. We've been very blessed in being able to acquire sort of data center-like facilities via our own building or via colo providers who have seen it wise to actually help us in our efforts. So we do a lot of BSD hosting, which I'll talk about a little bit later. We also host the Mozilla download folks. We're a tier 1 mirror for download.mozilla.org. In fact, we got a surprise update right before I got on a plane to come over here. And we also have mirrors.isic.org where we offer lots of open source applications like OpenOffice, Python, actually not Python anymore because they decided to go a different way, but KDE, Postfix, whoops. There we go. I don't think we're actually listed on their download page though, because they decided to have their own mirrors. But we have a lot of open source applications listed there. If anyone has any candidates, please let me know in email or after this talk. Kernel.org and mirrors.kernel.org. Yes, that is Linux. We host we host most of their download servers except for one, which is in Sweden. But we have the ones in the US, obviously, and we have one in Europe. They offer the Linux kernel, obviously, and mirrors.kernel.org has all the ISOs and different distributions that they download off of there. So they actually help us stress test our network. Because every time there's a Fedora core release or OpenSUSE or something like that, I grab the desk and hope that the network will stay together. But it always has, so I take great solace in that. Internet Archive, archive.org. The folks that come up with the Wayback Machine and so forth, we give them a 10 gig internet connection so they can help defray some of their transit costs. We also are participating in Wikisearch. We have one of their collection points. They're trying to come up with a open collaborative search engine. So we're participating in that, and we have much more than that. That's what kernel.org looks like. Big, massive disks, big, massive Opteron boxes, generates lots of heat, and they actually had to split recently the mirrors and kernel.org facility. This machine actually is now just handles mirrors.kernel.org. They actually now have a separate machine for just the kernel.org repository because apparently the version control system they use is a hog. Their words, not mine. Despite all that, we love FreeBSD. Most of our core systems run FreeBSD at ISC. So do many of our routers. They're Junipers. We also have a lot of Cisco routers, and I'd be remiss for not identifying the fact that we get a lot of help from Cisco in regards to networking gear. When I started at ISC full time, at least started administering ISC systems in 1999, it was basically little Pentium boxes running BSDI version 3.1 in demo mode. Sorry, Kurt. And side by side with our big DEC Alpha server running True64, because back then things like f.rootservers.net was handling the COM, net, and org zones. And those required a little bit more than 4 gigs of RAM, which is the max you could really stick in a i386 box at the time. So we had these big compact servers, and we actually had one handling all of our CVS and stuff at the time. So that was our big iron, and then we had all these little BSDI boxes around handling the web and mail and stuff like that. We have built our own internal edition of FreeBSD and packages. We, partly for philosophical reasons and partly because we kind of want to control our own destiny in regards to we don't, like one of the things we differ between our internal packages and what FreeBSD does, we don't compile bind because we normally compile our own. So we're usually testing bind or something, and we don't really need to have the one that comes with FreeBSD built, because then I have to fight it or have to at least remove it. Another thing we do is we use postfix, we don't use sendmail, so we strip sendmail out. So it's things like that. And the packages are, because we use slightly different ways, we use different make options. Like, we don't use X11 on our servers. So why do we need our packages to run X11? So it's sort of a management thing. It's just easier for us to, especially with the number of machines we have. The number of machines that we have running FreeBSD is somewhere around 300 at this point. So, so living the dual stack life. One of the things ISC has had as part of its mantra for the last several years is trying to help the adoption of IPv6 into the internet community. We've been running dual stack since about late 2001, early 2002. Most of our external public-facing services, at least corporate-wise, is all native dual stack. So we run Apache, Postfix, Bind, FTP, all over IPv4 and IPv6. Now, that caused some minor consternation, because this was back in 2001, early 2002. And the only thing, especially with Apache, the only thing I had to jump the shark and go to Apache 2 relatively early, because Wide at that time were doing the IPv6 support for Apache, and they decided to stop supporting Apache 1. So I had to make the big leap to Apache 2, which, considering the state of modules at the time, was a very interesting move. Fortunately, PHP finally worked. But I had a lot of help from the Wide folks back then to help us make the leap. Our routers were dual stack. Juniper and Cisco had basically already provided that support. My IPv6 rant. How many of you actually use IPv6 at your employer? How many of you use AutoConf? Okay. Now there are good uses for AutoConf. For the cases where if you want to have the connected home, where you have your toaster and your refrigerator and your those type of devices. Those are great for having AutoConf addresses because they don't really ever change much. Unfortunately for servers, that's a little bit of a harder problem. For those that don't know, EUI64 or IPv6 autoconfig is basically where it does a router solicitation to get the IPv6 prefix, which is the first half of the address. The second half of the address is the MAC address of the NIC you're connecting via. So if your NIC dies, the MAC address changes, unless you clone the MAC address. A number of times I have gone into trying to SSH into a box that had recently been recovered and watched SSH timeout because it was trying the IPv4 address, which is trying an auto configuration address which no longer existed, caused more trouble than it was ever really worth. So what I had started doing was just doing static addressing for my servers and just ditched auto configuration, AutoConf for this. Now, what many people, when I usually give this rant, a lot of people say, well, why don't you just use dynamic update? Dynamic update, if it was easy to use, yes. And we are trying to work on that, at least from a bind perspective. It won't really, we think it won't really gain traction until there's something like secure DNS, where you can actually watch the chain of authoritative changes and be able to verify that this is an authorized change. Because otherwise you could just watch an address change and not realize if it's actually a legitimate change or not. Fortunately, we've sort of tackled this because there actually has been a lot of discussion at IETF level about AutoConf and so forth, and that's part of the reason why we ended up developing DHCP version 4 with IPv6 support, because for large enterprises, they prefer the stateful addressing rather than sort of the randomness and not flakiness. It's just the randomness, the inherent randomness in EUI64 addressing. And we're actually probably going to change it so that the guests that are on our network will actually be using DHCP v6. So we'll manage their addresses that way. One of the prices you pay for our free hosting is you kind of have to eat our dog food. So you help us, we help you. Denmark keeps intruding upon my presentation. FTP.freebsd.org is available both IPv4 and IPv6. From ISC's perspective, we've done that since the beginning. I'm happy to say that our Danish friends at TDK, or friend at TDK, is also doing IPv6 now. I think everyone has for the last couple of years. The only service we actually don't support over IPv6 natively is CVSUP. If anyone really wants a project, try to teach Module 3 IPv6. I'm hoping at some point CSUP will spawn a daemon, and then I can finally get rid of CVSUPD, but until then. Okay, f.rootservers.net. This is what probably, other than bind, this is probably how you know us. I probably spent the better part of 4 or 5 years traveling around the globe, working like Johnny Appleseed to install all these nodes. We're one of the 13 root servers, and shockingly, we run bind. Actually, the root server operators, we try to strive for diversity. So many of the root server operators don't run bind, and we're actually fine with that because we feel that it's more important to have diversity than have 100% of the root servers running bind. So some run actually NSD, which is out NL Labs. VeriSign has their own thing that they run. So actually, they run bind and the Atlas. So we are at 42 locations worldwide using Anycast. This is a slightly different Anycast than what we'd use in the Bay Area. Actually, what we do is we go into an IX, an Internet Exchange, and we say, okay, we will set up an froot node at your location, and we advertise our address to the local internet community. And that address, that route actually doesn't go outside that local community. And then we have a couple of nodes that are global, that if you can't reach any of the local nodes, you go back to the global node to get your response. Because of this, we are actually more resilient, and we actually improve DNS performance worldwide. I'll give you a couple of scenarios. The last couple of years, we've actually been focusing our installs in the third developing countries, basically, like Bangladesh, and as well as countries that are behind satellite links and so forth. So your first hop is 600, 700 milliseconds away. We stick an froot node in that location. The round trip time goes down to about 12, 17, 21 milliseconds. So especially if in a country like Bangladesh, if their top-level country code, all their servers are inside the country, that means their DNS resolution doesn't ever have to touch a satellite link. So it makes DNS performance that much faster because you're not waiting 10 seconds to get your response to come back from the San Francisco or Herndon, Virginia, or Amsterdam, or Hong Kong. So that actually improves performance for the end user. Also, it distributes the load. In the case of the last DDoS against the root servers, which happened February 2007, we had an attack against a couple of the root servers, F included, but a lot of it was sourced in Korea. and in Asia in general. Our Korean or our node in Seoul got whacked, as well as the one in whacked, as in it basically sucked in all the DDoS, as well as in Beijing. We saw a little bit of a traffic increase in Amsterdam and San Francisco and Tokyo, but they were relatively short-lived. Well, basically what happened was that the source came from Korea. Fortunately, our root server node covers most of the Korean telecom companies in the country, or the telecom companies in Korea. So all that traffic went to our local node. It never crossed the Pacific. It never clogged up inner oceanic lines. Didn't affect 90% of the other root servers. So most people didn't even know it actually happened. I and a couple of other root server operators had a very hard time just trying to figure out what the hell was going on. But other than that, so DDoS attacks, it allows us to easily recognize where they're coming from because we know where the locations are and who. So if we see an attack in Asia, we know we can easily localize where the source is actually coming from because we know who we're pairing with, we know who we're dealing with. So we're dual stack. It's IPv4 and IPv6. We've actually unofficially been IPv6 enabled for last 4 years, but IANA and the Department of Commerce are very slow to update. They were worried about if we added IPv6, we'd break all Windows clients or something like that. So it took them a very long time to actually go through the process. We had to do a law study to verify that we actually wouldn't break the internet if we added Quad A records to the root server glue. So in early February, we got the roots. We and I think 3 other root server operators got Quad A records added, and we're now gathering about 100 queries a second, at least at the root server operators that are actually operating it. So about 300, 400 queries per second across all the root servers over IPv6. A third of our locations are currently serving IPv6, not all of them, partially because we only turn on IPv6 where we actually can peer over IPv6. There's no reason to turn it on unless there are actually people that actually peer to actually listen. Actually, most of our traffic right now in IPv6 is actually Europe. Paris and Amsterdam is the vast majority. Asia, not so, but we think that's partially because we haven't been very successful in getting IPv6 peers in Asia yet. But part of the reason I'm here is actually to help fix that. So, although this doesn't actually turn out very well. This is actually a map of most of our 42 locations. Hold it. That's the global. Those are the global nodes right there. We've got one in Monterey, one in Caracas, one in Santiago, one in Quito, Ecuador, Sao Paulo, Buenos Aires, Johannesburg, Cairo, Dubai, Tel Aviv, Karachi, Chennai, Madrid, and basically the list goes on and on. We've actually got a full list on our website. The ones in Asia, or at least the highlights, are Auckland and Brisbane, Seoul, Osaka. We're hoping to have one in Tokyo soon. Hong Kong, Dhaka, Bangladesh, and Kuala Lumpur, somewhere in there. What do we do for the BSD community? I left a good bit for last. We do a lot of hosting and co-location. We do colo for FreeBSD, NetBSD, and OpenBSD, as well as PCBSD. We handle their CVS or SVN and a hidden master for their mirrors to pull from. OpenBSD, we run the busiest US OpenBSD FTP server. Unfortunately, because I'm in the US, I don't think I'll ever get ftp.openbsd.org. Net and FreeBSD, they have cabinets at one or many of our facilities where we've got gear racked. NetBSD, we have all their public services, and like web, FTP, and mail, and stuff like that. FreeBSD, we have a lot of development machines. The other thing we help with is we help torture, well, code and developers. We have a mandate inside ISC to run release code. Every time, the FreeBSD developers have actually stopped saying this, but usually the first reaction I always get when they say I have a problem is, well, run current. No, we can't run current in a lot of these cases. Fortunately, in the case of like froot, it's very static, so it usually that usually doesn't happen with F, but actually it doesn't happen with F, full stop. But for a lot of the servers that we run public services on, we don't want to run current and then get slapped with something else and so forth. So, or find out that because of the code or because of the hardware we're using, it suddenly doesn't work. But Anycast actually helps with that because one of the servers we actually serve FreeBSD over is the machine that handles FreeBSD to ISC.org. That's actually locally Anycast at 2 locations, in San Francisco and in Palo Alto. So what I do with that is one machine is running 5.5 and is mostly rock solid stable and so forth, and the other machine I run 7. So if the machine breaks and falls offline, it withdraws its route, all the traffic goes to the other box. So I don't have to worry about when I go to bed, when the thing does a kernel panic 12 in the morning, I know that that FreeBSD has gone offline for 6 hours. So it's sort of hedging our bets. And with OSPF, you can give different priorities. So if for some reason I really need to stress test the box, I need to throw out all the packets that are going to FreeBSD to ISC.org, then I just change the priorities. So the box that's running FreeBSD 7 gets all the traffic. If it falls down, all that traffic then moves back. Normally we run it in a configuration that both machines actually handle the load. So they're sort of hot spares. So it depends where you're coming into our network from. If you come in from San Francisco, you'll get one box. If you come in from San Jose or our San Jose or Palo Alto location, you'll get the Palo Alto box. Hopefully in future with FreeBSD to ISC.org, I'm actually going to replace the FreeBSD 5 box with another FreeBSD 7 box, but that 7 box is going to run ZFS. So Palo better be prepared for some more bug reports. So we also hold final releases with last-minute showstoppers. You're looking at the person who personally held up both FreeBSD 5.3 and 5.4. Because of the previous reason of having to run release code, I would usually get a message from Robert Watson saying, hey, can you run this just before we release it? So I'd run it, and about 8 hours later it would fall over. And then there would be lots of core dumps or GDB traces and so forth, and I'd be giving developers access to the console and try to figure out what was going on, and then the release would get held up for 2 weeks. So partially this is because we are one of the busiest FreeBSD servers out on the internet, so we just stress test code. Alternately, with the last point, what do you mean you never actually tested this in production for IPv6? We're also the busiest IPv6 node in FreeBSD. So we were stress testing a lot of the COM and wide code that had been contributed that just never had seen the light of day in a lot of cases except in a lab. So this is a bit of the FreeBSD node at ISC. If you want to know where your Spark packages come from, it's there. It's basically a bunch of Netra 1s and Ultra 5s with a very shiny hammer box in the middle. And under that, this is where most of the AMD 64 packages come from. All these hammers and Celesticas, AMD 64 boxes. Up here is, I think this is Coverity getting rebuilt, thank goodness. And on top of that is Java Stable, where a lot of the Java Stable development is being done. Fortunately, because of this node, we were able to, at least Mark Lindemann told me that they were able to cut down the package releases for AMD 64 to basically they can do them weekly now instead of every 6 weeks or whatever that they were having to do before, which actually makes me very happy because we love AMD 64. And this is what half of ftp.freebsd.org looks like. The bottom bit is a little bit of Intel engineering spec hardware, which means I get very weird NICs and so forth that don't necessarily have drivers because Intel never officially ever released it. So it always causes some consternation. This is a fiber channel, the serial ATA RAID box. Trying to see the fiber channel or the fiber in the back. Unfortunately, I've got a duplicate version of this that will be the second bit that will replace the FreeBSD 5 box with. And so this is really nice hardware. I have slight pains in my heart that I just have to tell it, run in JBOD mode, and I'll just run ZFS all over you. So, but it's been very good. This is actually a 2 CPU dual core Xeon system with 16 gigs of memory. And now that I'm running FreeBSD 7 on it, I have to tweak and add more CD sub client or add more capacity to the CD sub. Right now we're restricting it to I think 15 concurrent clients. Part of the reason I went into running a FreeBSD mirror is because I always hated going to one of the CD sub mirrors and having to play war dial trying to get in. So I find it very refreshing that whenever I can actually open the tabs and add more consecutive clients. So for more information, mostly about Anycast, these are 2 tech notes that we've actually written about how we do it for using Anycast as a global distribution method. Also on our website, these URLs are rather long, so actually a short version is just www.isc.org. Click on publications, and then tech notes. I apologize, our website is horrible. We're currently working on fixing that. If you have problems, feel free to contact me over email, and I'll try to get you the documentation. So that's basically it. Any questions?
I don't know about IPv6 access segments. Is IPv6 access increasing or not?
It's increasing. I mean, one of the ironic things that we found, at least with the root servers, was that there were many ISPs who had like tier 1 ISPs, like the Global Crossings, Level 3. All the recursive servers could do IPv6, and they just switched on automatically. So actually, with one of our global nodes, most of the traffic was actually via the tier 1, the global network providers, was all their recursive server traffic. As for FTP, as I said, all of our services do IPv6. We get probably about, on ftp.freebsd.org, we usually get like five individual IP accesses, probably an hour, which is a lot. So one IP address may actually access about 20 files, but it's still just one address. So yeah. So it's slowly increasing over time. We're the primary IPv6 mirror for Mozilla. Any one of our hosted app guests gets free IPv6 connectivity. So we've actually been very fortunate. We've been able to provide FreeBSD with a IPv6 tunnel for their gear back at Yahoo, so they can actually test more IPv6 internally instead of having me be the guinea pig for it all. So yeah, so access is improving. It's just going to take time as people deploy IPv6. There was some slight worry that when we deployed IPv6 at the root, that things would just break because all this stuff that had been in a lab is all of a sudden getting out to the internet large, but that hasn't really happened.
Peter, repeat all questions, please, because people upstairs
sorry.
can't hear what people are asking.
Sorry. The question was, has IPv6, the number of IPv6 accesses actually increased recently?
Country, most IPv6 access, Japan or America or some country in Europe?
The question was, where do we have most IPv6 accesses? As I said, right now the majority of what we're seeing from F-Root's perspective is mostly in Europe. Obviously, there is a lot of IPv6 activity in Japan, like in the mobile networks. We don't see a lot of that because M-Root is actually operated by JPRS and WIDE. And they probably have a lot of IPv6 peering anyway inside the country. So a lot of that traffic's probably going to M-Root. But there is a lot of IPv6 activity in France. We knew that the educational network in France actually hard-coded our old address into their cache files, or their name.root files. So seeing a lot of traffic from France wasn't that big of a surprise. But North America, there's a lot of research networks that use IPv6. I know Hurricane Electric has been evangelistic about offering IPv6 tunnels. I know in Latin America, the RIR there, LACNIC, has been offering basically free IPv6 allocations to any existing ISP to try to jumpstart getting IPv6 in that country, because we've had most of the RIRs give out internet, Aaron, Wright, APNIC, put out statements that saying if you're going to be doing a large deployment, you have to seriously consider IPv6 because we are going to run out of IPv4 addresses eventually. I think the current hypothesis is something around 2010, 2011. So depending on who you speak to. So there's going to be IPv6 eventually. I'm fairly convinced of that, or I'm very convinced of that. It's just a matter of when are people finally going to realize that they have to make the jump. So, any other questions? Thank you very much.